Hello guys, welcome on Tesla Adventures. In this video, we'll discuss the oscillatory or simple harmonic motion of a mass which is placed inside a tunnel which is dug along the diameter of the earth. So this is earth, and let us imagine that there is a tunnel which is along the diameter of the earth, which is the greatest chord, and this mass is instantaneously at a distance of x from the center of the earth. The radius of earth is obviously r. So we know that the acceleration due to gravity at this point would be pointing towards the center of the earth, and therefore the force acting on this mass F would be equal to mg dash, where g dash is gmr or gmx by r cube. So the force acting on this mass would be gmmx by r cube. This is the force acting on this mass. Now let us see that this force is equal to m omega square x, which is the equation of SHM, and this is gmmx upon r cube, and cancelling m with m, x with x. Omega square is equal to gm by r cube, and omega will be equal to under root of gm by r cube. Okay, and this 2 pi by t is equal to, in fact this is, yes, this 2 pi by t is equal to under root of gm, which is gr square by r cube. So 2 pi by t is equal to under root of g by r. So t is equal to 2 pi under root of r by g. So this is the time period of SHM inside the earth, and it is equal to 84.6 minutes. Okay, and let us also see that what is the normal reaction applied by the tunnel walls on this mass. So obviously we can see that the net force acting on this mass is towards the center, and therefore there is no component of this force which is perpendicular to the tunnel walls. Therefore the normal reaction applied by the tunnel walls on this mass is 0. Now in the second case, we have created a tunnel along a chord of earth, and we have placed this mass at this point, which is at a distance of x from this point. This is the point at which the ball will be in equilibrium along the tunnel, because obviously at this point the net force acting on the ball would be directly in the downward direction towards the center of the earth, and therefore there would be no component of this force along the tunnel. Therefore we can say that the restoring force which is acting in the direction of tunnel, this is Fr is 0 at this point. Okay, so we can say that if this is h and this is acceleration due to gravity at this point, so let us suppose that this distance is r, small r. So we know that g dash will be equal to g r by r, which we have already discussed previously. So this, if this angle is lambda, so we can say that the restoring force will be equal to mg dash cos lambda. So restoring force will be equal to mg dash, g dash is gr by r and cos lambda, and you can see that r, small r cos lambda is x, r cos lambda is x. So we can replace this r cos lambda with x. So this is mg x upon r. This restoring force must be compared with m omega square x, and cancelling x with x and m with m, omega square is equal to g by r, while omega is equal to under root of g by r, and this is 2 pi by t, and 2 pi by t is equal to under root of g by r, and t is equal to 2 pi under root of r by g. So you can see that the time period is unaffected, and what we have studied in the previous case, in this case the time period was 84.6 minutes, and it is the same time period in this case also. So it is not this time period of SHM in the tunnel dig along in the inside the earth is not dependent on the position of the tunnel, that whether it is along the diameter or it is along some chord. But there is a different mechanics in this also, in which we can say that force component of a force or component of g dash along this direction is g dash sine lambda, and this component of force mg dash sine lambda is balanced by the normal reaction of the tunnel walls of the tunnel. And you can see that in the previous case there was no component of g dash perpendicular to the tunnel, but unlikely in this case there is a component of mg dash which is in the direction perpendicular to the tunnel, and therefore this component would be balanced by the normal reaction of the tunnel. So the normal reaction of the tunnel n would be equal to mg dash sine lambda, mg dash sine lambda, and we know that already g dash is g r by r sine lambda, where r sine lambda is equal to h. You can see that this is r and this is r sine lambda, which is equal to h, and h is a fixed value, fixed quantity, because the tunnel which we have dug along the earth is at a fixed height from the diameter, and therefore we can say in complete tunnel this h is fixed. So we can say that n is equal to mg into h by r, which is a fact that in this complete tunnel ball may be at any position, but its normal reaction by the wall of the tunnel would remain constant, and it would be equal to mgh by r. Let's suppose that if h is equal to r by 2, then we can say that the normal reaction would be equal to mg by 2. If we substitute the h as r by 2, then we can say that normal reaction by the walls of the tunnel in the complete tunnel would be mg by 2. So this is an important fact, that in this case the normal reaction would not be 0 obviously, and this normal reaction would be constant throughout the tunnel. So this was the SHM of the ball inside a tunnel of earth, and now in the next videos we'll be bringing some more important concepts of gravitation along with the Kepler's law and satellite motions. Thank you.